Hello friends, dear learners and my dear student. First of all, I welcome you to the lecture on ultraviolet visible spectrophotometry. Student, I am Dr. S.R. Labhade, working as Associate Professor in Department of Chemistry. Student, in previous lecture we solved some problem based on calculation of concentration, based on calculation of transmittance, based on calculation of molar absorptivity. In today's session, we solve some different types of problem based on the laws of photometric analysis, that is on the basis of Lambert's law. Therefore, first problem, that is a 32 ppm solution of a substance having molecular weight 176.0 gram per mole shows transmittance 0.45 in a 1.0 centimeter cell. Calculate the molar absorptivity of solution. Calculate the molar absorptivity of the solution. Molar absorptivity or a molar extinction coefficient, that we have to find out by using this information. Here concentration of a concentration of solution is given as a 32 ppm. 1 ppm means 1 milligram per liter. Therefore, here 32 ppm means 32 milligram per liter. Means 32 into 10 raised to minus 3 grams per liter. This is concentration in grams per liter. Now we can convert this concentration in moles per liter. Therefore, C is equal to concentration in moles per liter is equal to 32 into 10 raised to minus 3 grams per liter divided by molecular weight 176.0, and when we calculate this will have a 1.818 into 10 raised to minus 4 moles per liter. Now this is a concentration that we find out. That means 32 ppm solution whose molecular weight is 176 having concentration 1.818 into 10 raised to minus 4 moles per liter. Because for Lambert's law we have to require concentration in moles per liter. Now here we have concentration in moles per liter, then we can find out here as a transmittance is given, that is 0.46. Therefore, T is equal to 0.45. Therefore, A is equal to minus log T. Therefore, A is equal to minus log of 0.45, and which is equal to, by calculation, this A is equal to 0.3467. Therefore, this is the value of absorbance. Now we can utilize absorbance, concentration as well as path length for calculation of molar absorptivity. Therefore, epsilon or A is equal to epsilon into B into C. Therefore, here epsilon is equal to A upon B into C. A is 0.3467. Then B is 1.0 centimeter, and concentration that we find out here, that is equal to 1.818 into 10 raised to minus 4. And when we calculate all this, then we have this value equal to 1.907 into 10 raised to 3 liter per mole per centiliter. Therefore, here you can express all these values with unit. In this case, in Lambert case law, A is equal to epsilon into B into C. Here C is in moles per liter, B is in centimeter, and therefore this epsilon is in liter per mole per centimeter. But here it does not have unit, therefore here no unit for this A. But unit for C is moles per liter, unit for B is centimeter, and unit for epsilon is liter per mole per centimeter. Student, now we solve next problem, that is based on experimental analysis. Here problem is like this. From second problem, from the data given below, determine the concentration of unknown solution. Here data is like this, here concentration is given in ppm, and here concentration in ppm versus absorbance. Here concentration 1 ppm, absorbance is 0.07, for 2 ppm absorbance is 0.15, for 3 ppm it is 0.21, for 4 ppm, for 5 ppm it is directly given as a 0.36, and for 10 ppm 0.71, and unknown given a absorbance equal to 0.43. This much information is given to you. From this you have to find out the concentration of the unknown. In this case, as we know, absorbance is equal to epsilon into B into C. When we plot a graph of absorbance as a function of concentration, then we have a straight line passing through the origin, that called as a calibration graph or calibration curve. This calibration curve having a slope epsilon into B. Therefore, slope of the line is equal to epsilon into B. Therefore, product of epsilon and B that we find out from this slope, as A is directly proportional to C. Therefore, here if we know the absorbance of the sample, then we can find out absorbance of sample, then we can find out the concentration of sample. Therefore, AX earlier. For this purpose, we require a graph, and therefore by plotting a graph we can find out this concentration. But alternatively, how can we find out? We can find out the value of epsilon and B by using this data. Therefore, here value of epsilon B, that is equal to epsilon into B is equal to, that can be determined by absorbance divided by C. Therefore, absorbance divided by C is equal to absorbance divided by C is equal to product of epsilon and B, that is a proportionality constant. Therefore, for this value is 0.07, for this it is 0.075, for this is 0.07, for this is 0.072, 0.072, here 0.071, and when we calculate sum of this, it is equal to 0.358, and if we take the mean, that is epsilon mean, epsilon B mean is equal to 0.358 divided by 5, and finally this value is equal to, that is epsilon B is equal to 0.0716. And when we put this value into this equation, then we can find out the concentration of sample. Therefore, A is equal to, A is given, that is 0.43 into epsilon at B is equal to epsilon B into C. Therefore 0.43 into epsilon B is 0.0716 into C. Therefore C is equal to 0.43 divided by 0.0716, and when we calculate this, we have this value equal to 6.000 ppm. Therefore, in this way, generally at the time of practical, we are preparing the solution in this fashion. We are measuring the absorbance in this way. We can find out the concentration of sample by plotting the graph. Alternatively, we can find out the concentration by calculating the proportionality constant. And we have to match this value, which is obtained by using a graph and by using this proportionality constant. And if these values are matches with each other, then we can say our result is correct. Now we solve next problem. Student, now we solve the problem based on standard addition method. Standard addition method generally employed for determination of analyte concentration when we have to remove the interference from the matrix. Therefore, standard addition method is superior method for quantitative analysis. The problem based on standard addition method, that is number 4, a 5 ml, number 5, a 5 ml unknown solution of KMnO4 when diluted to 10 ml shows an absorbance of 0.23. In another 5 ml KMnO4 sample, a 2.0 ml of 0.001 molar KMnO4 was added. After diluting to 10 ml, the absorbance was here 0.43, here 0.41. Absorbance is 0.43, new absorbance. We have to find concentration of KMnO4 in the sample. This problem is based on the standard addition method. In this case, absorbance of first solution is measured, that is a sample solution. In a same sample solution, a standard is added and absorbance is measured. Therefore, two measurements are carried out, one with the sample, another with the sample containing standard. And from this, we have to find out the concentration of sample by using this formula. Cx is equal to Cs into Vs. Here Cx is equal to Cs into Vs upon Vx into Ax upon Ax plus S plus minus Ax. This is a formula that we can use for calculation of concentration of a sample by standard addition method. In this case, this is the concentration of a sample. Cx is a concentration of sample CS is the concentration of standard, volume of standard, volume of sample, absorbance of sample alone, absorbance of sample containing standard, and this is the absorbance of sample. We put all these values in this equation and we can find out here Cx is equal to, here Cs is, that is concentration of standard is 0.001 into its volume is 2 ml divided by volume of sample 5 ml into 0.23 divided by 0.43 minus 0.23. Here Cx is equal to 0.02 divided by 5 into 0.23 divided by 0.20. When we calculate this, we have concentration 4.6 into 10 raised to minus 4 moles per liter. Therefore, in this way, by using this formula, we can find out the concentration of sample by standard addition method. Sometime when the concentration of sample and concentration of standard are identical, at that time this formula becomes like this. That means here Cx is equal to Cs into this. We solve one problem based on this. Second type of problem. Problem is like this. A unknown solution of K2Cr2O7 shows absorbance 0.41 when diluted to 100 ml to another same sample of K2Cr2O7, a 0.005 molar K2Cr2O7 is added after dilution to 100 ml. The absorbance was found to be 0.60, calculate concentration of K2Cr2O7. In this case, both solutions are diluted to same volume, and here volume of sample is unknown, and therefore volume of standard is also unknown. Therefore, we can use this formula. Therefore, Cx is equal to Cs into Cs, that is a 0.005 into Ax is 0.41 divided by 0.60 minus 0.41. And when we solve this, Cx is equal to 0.005 into 0.41 divided by 0.19. Cx is equal to 0.005 into this, that is 2.158, and finally Cx is equal to 0.0108 moles per liter. That is the concentration of potassium dichromate. Student, in this way we solve all types of different numericals based on the laws of photometric analysis. With this we stop here. In next lecture we discuss the instrumentation of colorimetry and spectrophotometry, and then after we discuss the applications of the colorimetry and spectrophotometry. With this I invite you to my next lecture. Thanks for joining me. Wish you all the best. Keep learning. Happy learning.